we've got a question that is about solving systems of linear equations in three variables. Um, and we are going to attempt to solve this. So, um, first off, I know lots of people don't like it, but I'm going to solve this first one, find the value of A, for which the system does not have a unique solution. So that doesn't mean that there's no solution. It means that there's infinitely many solutions. Any values will work. So if we were going to do this in Gaussian row reduction, that means one row has to look like that. If we get a row that looks like that, we have no unique solutions because all the values will work. Okay? So using Gaussian row reduction, I screwed it up immediately. Such good confidence. 1, -7, 2, and -3. I've got 5, -2, -1, and 7. And I have -4, -5, 3, and A. All right, so my job is to just start doing the whole row reduction thing. So my first step is, I already have a 1 there, so I'm going to multiply this by -5 so that I can get this to a 0. So if I do that, I'd have -5, I'd have 35, I'd have -10, and I would have 15. When I add those, I get 0, which is what we wanted, 33, -11, and I also get 22. So that's my new second row. I'm going to do a similar thing on this top row, and I'm going to multiply it by 4 so I can get rid of this one. So that'd be 4, and then -7 times 4 is -28, and 2 times 4 is 8, and -3 times 4 is -12. That would yield me 0, -33, -11, +11, grabbing from the wrong thing, and A -12. Okay, so I'm going to rewrite my system just so I have everything written out. So 1, -7, 2, -3, 0, 33, -11, and 22. I've got 0, -33, 11, and A -12. So right away when I look at this, what I am seeing is if I add these two rows together, just as is, I'm going to get 0, 0, 0, and A +10. Remember, I'm looking to get to 0, 0, 0, 0, and then I would have no unique solutions or infinitely many solutions. So if I did that, A has to be -10. So that is how we get these 4 marks, is we just have to get to A is -10. I think that that's doable. Next, we need to consider the case when the system has infinite number of solutions and find the general solution to the system of equations in Cartesian form. Okay, so 2 things here. So I guess Cartesian form. Cartesian form is when we have a function in x is equal, so a function in x is equal to a function in y, which is equal to a function in z. That is what Cartesian form is. Now, each of these functions, I mean, this could be like 3x plus 2 equals 4y minus 3, and typically we end up with it just being equal to z. So that's what we're looking to form. So basically what we have to solve is for x, y, and z. Now, to do this, we already have a function with infinite number of solutions. That is what we created by getting this here. That gives us a function that has infinite number of solutions. So if I was just to rewrite out what I have in terms of this, so 1x minus 7y plus 2z equals negative 3, and then I've got 33y minus 11z equals 22. All right. And then this other one is just going to be a zero function, right? It's all zeros and it equals negative 10. So what we are going to do is we are going to take this and we are going to solve for each individual variable. So if I start with y here, so I'm going to solve for y. In y. All right, so when I solve for a function y, I would end up with, this is going to be 33y is equal to 11z's plus 22. And at the end of the day, I want to just have z on this side. This side I want just to be my z side. So in order to do that, I'm going to do 33y minus 22 is equal to 11z. Then I'm going to divide by 11, and I'm going to get 3y minus 2. So already we have the start of this function. We're going to have 3y minus 2 is the same as z. All right, now I just got to find a function in x, and I'm on my way. When I go to find my function in x, what I need to have is, again, I want to have it so it's x is equal to z. So I need to work on this function here, or this equation here, and I need to get this so that it's only in z's. To do that, I'm going to manipulate this one a little bit. I'm going to write this as y equals 1/3 z plus 2/3. Just divide by 11 or by 33. All right, so now I'm going to plug that in to this expression. I'll get rid of y's, I'll only be in x and z's, and then I'm basically just going to solve for z. So doing that quickly, I would have x minus 7 times 1/3 of z plus 2/3 of z, and then I'm plus 2z's, and all of that's going to equal negative 3. Expanding that, I get x minus 7/3 of z plus, there's no z on here, plus 14/3, right? And then plus 2z equals negative 3. Okay, I'm trying to solve for z. I want to get rid of those denominators. So to get rid of those denominators, if I just multiply everything by 3, the denominators go away. So that gets me 3x minus 7z plus 14 plus 6z's is equal to negative 9. Almost there. I want to get my z's over here, everything else over here. So that's going to turn into 3x and 14 plus 9. Oh, I didn't distribute my negative. Ha ha ha. That should be a negative. That should be a negative. So negative 14 plus 9 is negative 5. And negative 7 plus 6 is 1z, negative 1z. So now I have an expression for z in terms of x, and that is going to be 3x minus 5. This is the Cartesian equation for that system up there, okay? So that's what we have to do. I hope that's helpful.